you guys have a concept check. It's over 4-1 to 4-2, so it's up until this point. Add, subtract, and multiply polynomials. We are going to do a second part of 4-2 tomorrow. It's very short, but that will not be included on the concept check. This part will be included on your concept check. So doing your homework tonight is very important so you feel prepared during the concept check tomorrow. Okay. I would say the concept check, it has like 2 questions on it. It's probably going to take maybe 10 minutes. Okay, so it should be fairly short. Okay, so I took a binomial. Remember, binomial means it's a polynomial with 2 terms, binomial. And that binomial is a plus b, and I raised it to the power of n for several values of n. So if I do a plus b to the 0, well, anything raised to 0 is 1. Then I did a plus b to the first, which is just itself a plus b. Then I did a plus b squared, which you guys know we would have to do a plus b times a plus b and FOIL that out, right? So a squared plus ab, you don't have to write this down, plus ab plus b squared, and then these two combined to be that 2ab. And then I did it again, I multiplied by another a plus b, and then I did it again, and I kept combining like terms. So I want you to look at what you see on the screen and look for some kind of patterns. When I multiply that binomial by itself for several values of n. Don't worry about copying it down, focus more on the patterns. What sort of patterns are you seeing? Jacob, what do you see?
So the exponent, the b increases by 1.
Oh, the exponent on the b, the last term increases by 1, right? So right here it's b to the first, then b squared, then b cubed, then b to the fourth, then b to the fifth, okay? What other patterns do you see? Kaylee, you had a pattern?
I'm just going to say, like, the degree increases by 1. That's only because, like, the exponent of the original equation increases by 1.
Oh, so you're talking, when you were saying degree, we're looking at the a's? Okay, so you also notice your a's are increasing. This is a to the first, a squared, a cubed, a to the fourth, a to the fifth, which matches b to the fifth, right? Okay. Other patterns you see, Mason?
The b, because this is like standard form, right?
Uh-huh.
The b spot, the exponent keeps increasing too.
Yes, I think that's what Jacob said. The b's are increasing. Luke?
So if you start on the left with a, the exponent decreases, and then you get to the middle, and then it starts increasing on the b side again.
Look at what Luke is talking about. Luke, will you describe that one more time?
Yeah, so like on the a plus b to the fourth, you look at a's exponent going left to right, and it's decreasing. But then you get to where b has an exponent and going left to right, it's increasing. So with a, it's 4, 3, 2.
And what's this one?
That one's 1.
And what would the value or the exponent of a be over here?
0.
And then what else did you say?
And then with b, it's reverse.
Yeah, so what's the exponent for b over here?
0.
And then
1.
and that works on every line, right? So when you raise it to the fifth, the a's are going a to the fourth, a to the fifth, a to the fourth, a cubed, a squared, a to the 0. And the b's are going up. B to the 0, b to the first, b squared, b cubed, b to the fourth, b to the fifth. Cool. Anything else? Jacob.
So I can't remember what it's called, but like the number that's beside the ab, that's increasing. So it's like 2, 3, 4, 5.
Oh, those are coefficients.
Yeah, that's the word.
So you're looking just at the second term?
Yeah.
Okay. Gotta decide on a color here. I'll do red. So he's looking at the second term here. So like it's 2, it's 3, it's 4, it's 5. Notice anything else about those coefficients? Other coefficients? Josh?
And you lined up with the
Do they line up with the triangle?
The coefficients.
The coefficients. Oh no, look at your triangles. They're lining up with Pascal's triangle?
Yes.
Top row of Pascal is 1. Next row is 2 ones, right? It always starts with a triangle of ones, I say. And then, like Elise told me, the first and the last numbers were always ones. And then I think maybe Chloe told me that I could add the 2 previous terms to get the next term. So 1 plus 1 was 2, and then 1 and 1, and then 2 plus 1 is 3 and 3. And then when I look at these coefficients, I've got 1, 3, 3, 1. Well, that's that row, isn't it? So this is row 0, remember? I said this is going to be row 1, this is row 2, and this is row 3. So notice I used 1, 3, 3, 1 when I raised by binomial to a 3. If I'm raising my binomial to the 5th, which row of Pascal's do I want?
1.
To the 5th power, I would want row 5, which is really when you're counting down the 6th row because we start at 0. So I would continue my work here. This is row 4. And then here's row 5. Squeeze that in. Nope, can't do it. There it is. And then look. 1, 5, 10, 10, 5, 1. So, we can do things the long way. We could take the time to multiply a plus b times a plus b times a plus b times a plus b times a plus b. Or we could pick up on these patterns and use Pascal's triangle to expand our binomials. Which is what we're going to do. So, here's what you need to jot down in your notebook. I did some like highlighting of things just so like it's a good color coding. If you have colors or highlighters or something, you're welcome to use those. If you need some color pencils or something, you can grab from the side shelf. This is called binomial expansion. You're expanding a binomial through multiplication. You're raising a binomial to a power. So I'm going to give you some time to jot that down. Okay, so if you take some binomial, a plus b, and it's not always going to be a and b. I could put numbers in there, right? Like you can see my next example is going to be x minus 5, or I could have 2x plus 4, whatever I want. And I raise it to the nth power. I will have n plus 1 terms. So if I raise it to the 5th, I will have 6 terms in my final answer. If I raise it to the 2nd, I will have 3 terms in my final answer. Pascal's triangle, that's where you're going to get the coefficient for each term. So you need to be able to reproduce Pascal's triangle. Remember that Pascal's triangle starts with a triangle of ones. Okay, so I can do 1, 1, 1. And then use Elise's patterns. It will start and end with a 1. It will always have one more term on the next row. Use Chloe's pattern. 1 plus 1 is 2. 1 and 1. 1 plus 2 is 3. 2 plus 1 is 3. And so on, so that you can get the rows you need. I probably won't have you go above row 6, right? And that would be too much. This is kind of what Jacob and Luke and someone else was touching on, those exponent patterns. So A begins with the exponent of n, with the highest exponent, and then it decreases to 0. B begins with the exponent of 0. It starts at its lowest and then increases to n. Okay, so they're flip-flopping. And we're going to do an example. We're going to do x minus 5 cubed. Okay, so if you want to, you can label like what A, B, and N are. So if you feel like that's something that might be helpful to you, you can go ahead and label that. A is x, B is negative 5, so you have to be careful with that. And then your N value is 3. Since I'm cubing it, I should have one more term than that, which will be 4 terms in the end. Okay, and since I'm doing 3, raising it to the third, I want the third row in Pascal's triangle. When I create Pascal's triangle, remember the top row is row 0, 1, 2, and 3. So those numbers, 1, 3, 3, 1, or the row with 4 terms in it, are going to be the coefficients to my expansion. Okay, so I'm going to do 1, 3, 3, let's squeeze it in, 1. Okay. Now, these are the different terms, so those are the things that are getting added. And then I'm going to be multiplying those coefficients by the first term and the second term raised to different exponents. So remember, for all of the A's, the thing at the beginning of the binomial, you start with your highest exponent and go down. So I'm going to start with x, and that's going to be x to the third, x squared, x, and if you want to say x to the 0, you can, or leave x out, right? Okay, so whatever you prefer. I'll put it on there just for notes purposes. And then the b starts with an exponent of 0 and goes up. Now, if your b value or your a value is negative, you should protect it with parentheses. Okay, so I'm going to do negative 5 to the 0, negative 5 to the first, negative 5 squared, and negative 5 cubed. When you break it down into a pattern, it's really not so bad. So we want to be looking for that pattern we saw with Pascal's triangle. All right, now I just got to simplify things. Okay, what's going to happen with negative 5 to the 0?
It's not going to be there.
That's just 1, right? Okay, so this is 1 times x cubed times 1, which is just 1x cubed. Okay, what's going to happen with negative 5 to the first?
It's going to be negative 5.
That's just negative 5. So 3 times negative 5 is negative 15, and that's going to be x squared. All right, next one. What's going to happen with negative 5 squared? Going to be 25. And then I have 25 times 3, which is 75x. And then on the last one, x to the 0, we had mentioned was really just going to be 1. And then negative 5 to the third, negative 125. Think about 5 quarters, because 5 times 5 is 25. If you have 5 quarters, that'd be $1.25. So this is negative 125. So then we get minus 125. Now, that's the same answer we would get if we wrote out x minus 5 times x minus 5 times x minus 5, multiplied it once, multiplied it again, but this is probably a lot faster. Questions about how we did what we did, why we did what we did, where something came from? I'm going to give one for you to try. Again, this is probably like the hardest part about today, and I don't even really think it's that hard if you can pick up on the pattern. Okay. You guys try 3x plus 2 to the 4th. Now, you got to be careful here. Remember, you got to protect your a and b with parentheses. Okay. So you can talk to your groups if you want. What row are you using? What numbers? What are you doing with your exponents? All of those things.
So you use row 4 then?
I heard some groups talk about using row 4. Row 4 looks like 1, 4, 6, 4, 1. It has 5 terms. It should have one more than the power that you're raising it to. So those will be our coefficients. What's your a value? 3x. Put that in parentheses. What's your b value? I don't see any. Where did you get all your stuff from? I'm gonna start setting this up so if you're having some trouble getting started. A is equal to 3x, b is equal to 2, n is equal to 4. I've got my coefficients 1, 4, 6, 4, 1. Okay. I'm going to be adding in front of those. Those are the coefficients. You have to have them from Pascal's. Now your a usually starts with which exponent?
The high one.
The highest. So what's the highest exponent in this one?
4.
4. So your a is 3x. You need to put that in parentheses and raise it to the 4th. Then you're going to do 3x cubed. Then 3x squared. Then 3x to the first. And 3x to the 0.
I did it wrong too.
What are you going to do next?
Add b.
2 to the 0. 2 to the first.
2 to the second.
2 squared. 2 cubed. 2 to the 4th.
2 quadrant.
You're going to start with your b's and you're going to go up. 2 to the 0. 2 to the first. 2 squared. 2 cubed. 2 to the 4th.
If it's to the 0, is Is it just automatically 1?
Yep.
Okay.
Anything raised to 0 exponent is 1. You know that from algebra 1. Now, sometimes my students think there's a lot of stuff going on. So some people, like, you know how you have to multiply all this stuff together? Some people like to group these things, which is okay if you want to do that. If you want to separate them, like, okay, these are the three things, right? I have my coefficient for Pascal, I have my a to an exponent, and I have my b to an exponent. Okay, and so if you want, you can group them. You use parentheses or brackets like I am, whatever you want to do. Can I ask you at this point, just in terms of self-check, what do you notice about like all the pairs of exponents for each term? 4, 0, 3, 1, 2, 2, 1, 3.
They all add to the highest degree.
They all add to the power. So that's a nice way for you to check that you didn't make a mistake with your exponents. That if your n is 4, when you write out your terms, they have to add to 4. Sometimes you might start going down on A's and then you start going up on A's, so you have to fix that. So you have to be careful. Okay, now I'm going to simplify. This is 1 times, if I'm doing 3x to the 4th, what's 3 to the 4th? 81 times x to the 4th. And then 2 to the 0 is 1 plus 4 times 3 cubed. 27 x cubed times 2 plus 6 times 9x squared times 4 plus 4 times 3x times 8 plus 1 times 1 times 16. Alright. Now I can do my multiplying. This is 81 to x to the 4th. Somebody help me out here. 8 times 27? 216 x cubed. This is 50. Was that 54 times 4? 216 as well? Oh, that should be an x squared, shouldn't it? Let's see. 12 times 8 is 796. And then plus 16.
Oh, yeah.
Okay, questions, concerns? Where are my numbers coming from? Why am I doing what I'm doing? There are some people who are not with it today. Get on this train. This train is moving down the tracks. Yep.
How are you getting like the 9x squared?
Oh,
Like,
when I do 3x squared, I have to square 3 and square x. So 3 times 3 is 9. And then the 4 is coming from 2 squared.
okay.
And the 6 is the coefficient from Pascal. So, like, a very common mistake for people to make on this one is to say 3x to the 4th, 3x cubed, 3x squared, 3x, right? To not raise 3 to the exponent. But it should be 3 to the 4th, x to the 4th, 3 to the 3rd, x to the 3rd, 3 squared, x squared, 3x. Okay? Any other questions? Okay, so you do have some problems on the homework assignment. They are odd. The answer is in the back of the book. I'm going to need you to practice those for tomorrow. Okay. We're going to move along to some easier topics, like adding and subtracting. So I'm just going to let you in your groups talk real quick about how you would add and subtract these polynomials.
Whoa, whoa. Okay, so let's write it out. So x squared plus 2x
I
plus 3
changed that like the x's.
parentheses.
Okay, so
So let's simplify these terms. 3x squared and 5x are like terms. KJ.
Or no, maybe it's like
Back it up, back it in.
yeah, I don't know. So like how many is 3 big minus 7. So then you get 4x.
No, it's not a lot.
Okay, let me interrupt. What did you guys say you would do to add those polynomials in that top problem? Combine like terms. Thank you, Darby. I mean, haven't we done this before with complex numbers? Yeah, if we were just adding imaginary numbers, we would add like terms. That's what adding and subtracting in math is, right?
Let's do this.
So x squared plus 3x squared is
4x squared.
4x squared. And 2x minus 5x.
Negative 7.
Negative 3x. And 3 minus 7. Minus 4. There you go. It's a new polynomial.
Is there like a standard form or?
It is in standard form. The exponents are decreasing from left to right.
Okay.
Okay, what did you say about subtracting?
It's just the same thing. We're just subtracting.
What would you warn a student, maybe an Algebra 1 student, about what can be your downfall in subtraction?
Negative numbers.
Not distributing the negative, I heard from that group back there. Not distributing the negative. So you know what I do with subtraction? I change it to addition.
Boom.
To change it to addition, I'm just going to add the opposite of every term behind the subtraction sign. So this is going to turn into plus, which means this is really negative 2x squared, positive x, negative 7. And then I can go through just like I did in adding and just combine like terms. I don't have to worry about remembering to subtract. Okay. So let's see. 3x cubed doesn't have a like term. Negative 2x cubed plus negative 2x squared plus negative 2x squared. Negative 4x squared. Plus x. 2x. And negative 1 and negative 7? Negative 8. If you have 3x squared minus 3x cubed, that should be. That's why I got that wrong. 3x cubed minus 4x squared, and then you have plus 6. You didn't distribute your negative. So you're falling into the trap that Algebra 1 students fall into, and you're better than that. Okay? So not too bad, right? If you want, write what Darby told us in the margins of your notebook. Combine like terms. That's all you're doing. Don't make it harder than it is. Okay, I'm going to give you a little bit of time to chat with your group members. How would you multiply these polynomials? Go ahead and have that chat.
So would it be 2x to the 5th?
When you multiply powers, you add the
Oh, got me up there.
Okay, a few minutes. We'll try it another time. Good enough. I don't know.
Don't know how to multiply? Oh.
I don't know why.
Oh, well, like, how do you just do x squared times x cubed? When I wrote out x squared, that would be minus x. Wrote out x cubed, that would be
Guy right now.
times x times x. When you do it times x, it's
The only time I'll spend is like if you lose, then you have to stay. Remember that time?
What did you guys talk about?
But for the first one, we just distributed it.
Mhm.
And then
I was
the second
trout,
one, we
trout
talked
slow.
about boiling, we can't do that.
I usually go
Well,
with
You
it's
could
trout.
do a process like boiling,
Yeah.
it's just that there are more terms. Yes, I agree. Okay, so as I'm walking around, most groups are talking about, like in the first one, distribution. So you got to multiply 2x squared by everything. Now there's some really good conversations happening about what to do when you multiply powers. Powers are things that have a base and an exponent. So 2x squared times x cubed, what do you do with your exponents?
Add them.
Add them. That's 2x to the 5th plus 4x to the 4th minus 6x squared. Did I get that right? Okay. Now, what are you going to do on the second one when it's a trinomial times another trinomial? Okay, some people are talking about foiling. Foiling is really for a binomial times a binomial because you only end up with 4 terms, first, outside, inside, last. But the process is still the same, right? So foiling, multiplication, distribution. When I do this, I like to go like this. Take the first term, distribute. Okay, so I'm going to distribute to all 3 of these. That's going to give me x to the 5th minus 3x to the 4th plus 3x cubed. Then I'm going to take this middle term, which is negative 2x, and I'm going to distribute it. So negative 2x times x squared times negative 3x times 3. So that's negative 2x cubed, which to make my life easier, I'm going to stack under the other x cubed. That way I can just combine like terms. And then negative 2x times negative 3x is plus 6x squared. And negative 2x times 3 is negative 6x. They don't have any like terms. And then I have to keep going, right? Take this one and multiply it by everything. Well, then everything's just going to be equal to itself. So that's going to be positive 1x squared minus 3x and plus 3. I know that this takes up a little bit more space on your paper if you use 3 lines for that, but that works out real smooth for combining like terms, right? If you stack them where they belong.
Stack and add.
Yep, stack and add. So we got x to the 5th minus 3x to the 4th plus x cubed plus 7x squared minus 9x plus 3.
He's copying me, no.
Awesome. That's great. Did you plan it?
Great
Even
minds
more
think alike.
special. Okay, any questions or concerns on multiplying? Okay. Now, this is that top one, 5x minus 2 squared. Could you use Pascal?
Yes.
Yeah, but probably for squaring, it would be either, yeah, just FOIL it out. But this is that moment of, remember that date we wrote down in our planner? Whatever day was that? Like September 17th, 2018, when Miss Cronky told you that one time. Okay, I do not want you to tell me this is 25x squared plus 4. That's not a thing, right? Some of you know. I do that all the time. So I like what Jess said. If you see something that's being squared, think about what squared means. It means multiply it by itself, so you should FOIL it out. This will turn out to be 25x squared minus 20x plus 4. Okay, so just as a side note, remember that day. I'm going to bring it up about once a week, and people are still going to do the thing I told them not to do on September 17, 2018. I don't know what more I can say to you guys. Okay, if you were asked to write the expression for the volume of a box,
Length times width times height.
thank you. Volume equals length times width times height, with a length that is 3 units less than the height, and a width that is 1 unit more than the height. How would you write the length, width, and height for that?
It would be like length.
What would length equal? H. The length is 3 units than the height. So that would be h minus 3. And the width is 1 more than twice its height. So 2 times h plus 1. And h is h. And then we use Mason's formula. H times h minus 3 times 2h plus 1. How would you multiply 3 terms out?
Would you just FOIL h into all of them?
Okay,
Distribute.
well, you would distribute h into 1, right? So if you multiply h into this factor, it's going to be h squared minus 3h.
So then would you just do into that one?
And then you do 2h plus 1. But you don't distribute h to the other factor. Okay, so you can only multiply 2 at a time. So multiply 2 at a time and then multiply by the third one. So I can do that fairly quickly. Let's see, that's going to be 2h cubed plus h squared minus 6h squared minus 3h. So 2h cubed minus 5h squared minus 3h. That's my volume. Okay. Now this volume question is going to come back a lot. So it's a polynomial, right? The volume, and it has 3 factors. Okay. Length, width, and height. Okay. Now, you don't have to write this part down, but you might want to write down page 167, special product patterns. Did I not say something that confused you that you had to Google it? Did I leave something out? I leave something out, just tell me. Yana, you give me looks today. What are you trying to say?
Is this our homework?
You can tell me after class. No, I'm just saying, I'm just talking.
Just write that down.
Just write page 167, special product patterns. Now, if I'm multiplying a plus b times a minus b, I know that that's a squared minus b squared. That's the difference of perfect squares in reverse. Okay. If I multiply a plus b squared, that's the one that I warned you about. It is not equal to a squared plus b squared. It's equal to a squared plus 2ab plus b squared. There's always a middle term right there. So, like that one where Jet said, just FOIL it out. I didn't even have to FOIL it out. I knew it was going to be 25x squared, because that's a squared, and then it was going to be minus 2 times 5x times, what was the other one? 2, which was minus 20x, and then it was going to be plus b squared, which was 4. Okay. So I used the special factor pattern. And then likewise, there's one for a minus b squared, and that's a squared minus 2ab plus b squared. So if you want to use those special factor patterns and work smarter, not harder, feel free. If you don't want to use the special factor patterns, then you're going to have to FOIL it out every time. But I'll tell you, like, if you get to know some of those special multiply patterns or product patterns, that will make your life a little bit easier going forward in all your math classes, no matter what you take. All right. Your homework assignment. These are odd problems for the most part, so you should be doing what? Checking your odds in the back of the book. I think, let me check my answer key. Which ones are Pascal's? Pascal is 43 and 45. So I'm going to put a little star by that. I mean, I think most of you should be able to add, subtract, and multiply polynomials without too much extra work. However, Pascal's triangle is going to require a little bit of work on your part, and you're going to need to be able to produce Pascal's triangle on your own. So you have about 5 minutes. I will pull up the beginning part of the homework assignment, and you can get started.